Hello, everyone. My name is Molly McKinley, and I'm here to talk to you today about how you can use Web3 or the distributed web to store, secure, and distribute important research data. I'm mostly aiming this talk towards researchers, people who interact with large amounts of data or are trying to specifically work around making data more accessible, more resilient, more collaborative, and more resiliently preserved for the long term. And especially folks who are excited to use open source tools and protocols in order to make that possible. Today, I want to share three stories. One about how scientists have a need to make data more resilient over the long term. Another about the verifiable need to address and be able to prove that data is authentic from end to end. And finally, one about using tools to better collaborate around data. All right, the first story is about the Environmental Data and Governance Initiative, also known as EDGI. Back in March of 2019, there was a big chemical fire in Deer Park, Texas. And this group got involved when another group came to them about starting a legal case where maybe 5-10 years from now, they wanted to be discussing the impacts of this chemical fire. So what had happened was there was this huge fire and a lot of benzene was released, and the response on the ground to this fire was really, really terrible. Unfortunately, the people who were in charge of fighting the fire got the wrong order of magnitude about how many parts per million was dangerous. So they sent in firefighters with no breathing apparatus. They sent workers back to factories next door, and they sent school children back to schools next door. And unfortunately, benzene is a very active carcinogen, which sadly might mean that many of these people could develop things like cancer or other bad repercussions from having breathed in all of the benzene at the time. And also, unfortunately, the people who are responsible for the fire and for fighting it are also the people who are hypothetically responsible for preserving the data that would prove culpability about this response. And even worse, when the Environmental Data and Governance Initiative started looking into this case, it was identified that one of the relative monitors about air quality data was actually taken down during the fire. So there's a potential for foul play. And so this group came to the Environmental Data and Governance Initiative because they needed a place to archive that data that was resilient, where it won't disappear and they can prove it's the same data, even 10 years later when they're taking this case to court and they're looking at the full repercussions of this fire. The next story is about Starling. Starling did a collaboration with Reuters about authentic content authoring, where they were documenting the voting conditions in the 2020 US primary. They want to prove the validity of information, like an image or video that they take in the field, all the way from capture to storage to validation or verification of this information with the viewer who's consuming it. And Starling worked with Reuters to create a framework for end-to-end data integrity. It was a partnership between the USC Shoah Foundation and Stanford's engineering department, where they wanted to take the professional imagery from Canon cameras and mobile phones being used in the field and associate the rich sensor data on the device, things like time, location, GPS, gyroscope, all of these awesome pieces of information that we have on the device, and associate those with a photograph or video being taken, and collect the metadata from the device and create a secure package that associates that metadata and that image or video together. And that can prove when and where a photo was taken. What they did is they wanted to be able to distribute that in a way where they can encrypt and secure that package and store it in a decentralized network, so that they can distribute it across many, many devices and use verifiable proofs, verifiable ways of looking at the data so that they can prove that it's being stored continuously over time and that no one is tampering with this information or in cases where that metadata is inaccurate. And they want to enable everyone to help store that information, and then also when viewing through a gallery, be able to see that verified metadata about where and when the photo was taken. Story number 3. Earlier in 2020, the New York City government started publishing a set of PDFs about how capital is being put to use in various projects across the city. However, that data was in a pretty inaccessible format, buried in deep inside PDFs, limiting the groups that could take advantage of it and kind of interact with it. So Query, QRI, saw a need to make that data set more accessible and augment each project described within it with the geodata so that it could be visualized and mapped and become much more accessible to the populations these capital projects are trying to serve. So instead of taking on this as kind of a solo pro bono project, they actually aligned a community of volunteers to pour through this data for their own relevant parts of the city and geotag different parts of this data set collaboratively. Then they enabled not just kind of threading this information together, but also putting the entire version history of new geodata that's being added onto Query, which is a package manager for data sets, which allows lots of different people to contribute and pull request and fetch data from all sorts of different parties. And anyone then can build on top of that data set as well and augment it with their own additional metadata or build applications that are backed by it. And so aiming to go from a inaccessible data set to something that is collaborative and empowers many groups to utilize it together. So how did these three different stories achieve what they were trying to do? It's by using a new stack of protocols and tools which make up Web3, the new version of our interwebs. So what is Web3? The big change from Web2, which is the web most of us use today, is trust. Read, write, and trust. With Web3, we get verifiability at the core layer of the web. Web 1.0 was about linking content together across the internet, all static stuff like documents, papers, etc. Web 2 was about linking programs to that content and building rich dynamic applications like editors and markets and chat applications. And what's going on now is that we're actually inverting that relationship, linking content and programs directly to each other, which lets applications bypass intermediaries and gain public verifiability. So Web3 is actually turning centralized applications into decentralized protocols. I'll give a short description of what Web3 is here, but for a deeper dive, I highly recommend this talk by Juan Benet from the Web3 Summit in 2018. I'll stick a link in chat. From that talk, here is Juan's Wikipedia definition of Web3. It's a movement to make the web and the internet more decentralized, verifiable, and secure. It builds on trustless infrastructure, removes intermediaries, and gives users more agency. The key innovation to achieving that trust is making things verifiable. It's the key primitive to this entire space, unlocking all of the other associated benefits. Verifiable means to be able to be checked or demonstrated to be true. If someone is providing a service that is verifiable, you can check that they're actually providing the service they say they are. For example, if some service makes a verifiable guarantee that they aren't looking at your data, you can check that and audit it and validate it's actually the case. If you fetch verifiable data from another person in your network, from another device, you can check that the data that you receive is the data you asked for and that it is complete and untampered with and exactly as expected. Much of the web that we use today is centralized into corporate silos. And the reason for this is simple. It's easy to manage and it worked. Unfortunately, it's not very resilient. There is, in addition to kind of a single centralized point, a single point of failure. And there's also a central point of control. When you have a centralized system, the central node controls what the edges of the network can do and what they can pass between each other. So in a way, the network becomes owned by that central node. In the Web3 movement, this is aiming to move towards distributed or decentralized networks. In these, all of the nodes share in the coordination responsibilities, which is more difficult, but also much more resilient because you can cut more links, bring down many nodes, and still have parts of the network that are interoperating and functioning together. Matrix, which many of us are using for chat during this conference, for example, is a decentralized network, and Ethereum and many blockchains are fully distributed with all nodes being peers. The Web3 movement is now organizing into a set of common building blocks, creating a stack of protocols and capabilities that make the web verifiable. Today, I want to talk to you a little bit about some of the protocols that make up that stack and how they deliver the properties and guarantees that the three stories we just talked about, from EDGI to Starling to Query, need in order to make their data more resilient, verifiable, and collaborative. The first of these protocols is IPFS, the Interplanetary File System. IPFS enables verifiably addressing and distributing content in a peer-to-peer network. Compared to HTTP, which uses location addressing to find data, which creates these central points of failure and control, IPFS interconnects devices and allows them to exchange data directly without a central intermediary or being connected to the full rest of the network. You can have a couple of nodes, often their own subnet, interoperating and exchanging data peer-to-peer without interconnecting with the rest. The way it achieves this is through content addressing, referencing data by what it is instead of where it's located in the network. This simple primitive switch helps IPFS address a whole host of problems that the web faces today, from enabling applications to work better offline or in poorly connected regions, to making data addressing much more resilient, since links no longer change when a file is moved or hosted by someone else. IPFS uses libp2p to route between peer-to-peer nodes and discover data in the network. libp2p is a modular networking stack used by Web3. It includes many different transports for how you interconnect peers within the network and help you discover new peers with the data you're looking for. The final layer of this stack is Filecoin, which adds incentives for data persistence. Filecoin acts as the decentralized storage network for Web3. It's the verifiable protocol for incentivizing untrusted peers to store data over time. The mission of Filecoin is to create a decentralized, efficient, and robust foundation for humanity's information. This mission guides the project in ongoing development and what it aims to do. To achieve this, Filecoin actually acts as a lot of things. It's a network, it's a spec for others to implement, it's a medium of exchange for file storage, a token, and a thriving ecosystem of tools and projects building on top. Today, we're going to focus mostly on the storage network aspect and how that works. So Filecoin is a marketplace that matches clients who want to store data with storage miners who are aiming to provide storage as a service. The network manages the interactions between the two sides of this marketplace. When a storage client comes to the network, they select miners based on a number of dimensions to store their data. Those might be location, price, storage capacity, reputation, or even offline relationships between parties outside the network itself. Maybe they're in the same area and they already know each other, something like that. Once a storage deal is made, clients transfer their data to the miner and lock up tokens to pay for successful storage over time. The network regularly asks miners to generate proofs, in this case, proofs of space-time, which verify they're doing what they say they're doing, which is storing the client's data correctly over time. Miners then send these proofs to the network, and the network sends appropriate payment from the funds that the client locked up at the start of the deal. In this system, parties need to be able to trust that the network correctly incentivizes honest behavior. And Filecoin achieves this through cryptographic proofs that anyone can audit or verify. Again, we're putting this verifiability directly into the protocol layer. Parties participating in the decentralized network might play a few of these different roles. You have clients who are purchasing storage and retrieval of the data they've stored. You have miners who are providing storage and retrieval for a fee, and also verifying each other's proofs of space-time as they interoperate in the network. And then there's a whole huge community of developers who are building projects, tools, and services that make this network more accessible to various parties. Together, these protocols we talked about, libp2p, IPFS, Filecoin, form a stack that allows addressing, transferring, and persisting data within a decentralized network. And there's also, conveniently, a large ecosystem of tools and infrastructure and services built on top of that stack, like Query that we talked about earlier. So how did these stories that we talked about earlier utilize Web3? Well, for EDGI, in addition to using traditional routes for storing their data, the researchers added the Deer Park air quality data to IPFS. They worked with groups like Query and others to help persist that content between many different volunteer nodes to make sure that it would be resilient across time and space. The Starling team is actually taking their verifiable image metadata packets and storing them to both IPFS and Filecoin, distributing the data across many globally distributed peers and being able to audit using those Filecoin proofs that ongoing storage is happening correctly. And finally, Query is using IPFS to version control and collaboratively update their geotagged project database. It allows new app developers to build on the same data set and researchers to collaborate on creating new augmented versions of that data. In addition to the 3 stories we talked about, a whole ton of organizations are already using these protocols to archive and distribute precious data sets. There's IPFS Wikipedia, which helps make this critical knowledge repository accessible in countries like Turkey and Thailand. There are collaborative IPFS nodes, which are helping redundantly store Project Gutenberg cultural works. I have the Spanish version running on my local machine right now. And there's a whole team that's actually working to store OpenStreetMaps on IPFS and building new interfaces and applications on top of this collaborative data set. So that's a little bit about how people are using these protocols today to solve real problems. But how might others use it, and what's coming that might make this even easier in 2021? Well, 3 new advancements are in the works that started in kind of September, October of last year and are getting more and more accessible. One is Filecoin Plus. The next is Powergate, and the third is Slate. So Filecoin Plus is a program in which parties who are participating in the Filecoin network can verifiably register themselves with a notary about the data that they're storing in the network. This helps make sure that we're using Filecoin as expected to store useful data for humanity versus just having miners who are storing data with other miners. What happens here is that as you sign up to be a Filecoin Plus client, your data becomes much more incentivized for miners to store in the network. And actually, you'll see a number of miners who are offering free storage now for verified data within the network, creating a big incentive for people to bring massive data sets to utilize the capacity that's been committed to the Filecoin network. The next of these is Powergate, which is developed by the team at Textile, which builds a ton of developer tools and APIs for working with Filecoin and IPFS. And Powergate makes it really easy to build on top of Lotus, which is one of the Filecoin implementations, and IPFS as well. It has a whole set of developer tools, which they've actually been making a ton better. So they just, a couple of weeks ago, released Powergate V2, which has a whole new set of APIs around deal management, getting fast feedback on deal status in Filecoin, and then being able to index and route between deals that you learn about on the network. So you can import a whole repository of existing deals and then be able to build up a knowledge of where you can fetch various data from in the Filecoin network. They're also working on miner reputation. So as we talked about, clients, when choosing people to store their data, have a whole list of things that they might be looking for, from location to other aspects of how resilient a miner would be for their data set. And so Textile is helping build up that information and embedding it into things like Powergate, so it's really accessible to developers. And finally, Slate is actually a tool that's built on top of Powergate in order to kind of make a really smooth user experience for storing data and files. And it ends up being just a really smooth way for building up a UI or a collection, which is then backed up to Filecoin and IPFS, making it fully accessible there. So that's a couple of ways in which IPFS and Filecoin are better serving people's needs in the coming year. And really, the next step is we'd love to hear from you. There's a lot more that we can do to make this even more accessible to folks. And so we'd love to hear about your pain points in working with large data sets or trying to make sure your data is resilient or collaborative. And we'd love your help suggesting various tools or capabilities that we can add in order to make this even more useful. And if you're excited and want to start getting involved, there's actually a lot of pilots and hackathons happening, even just this quarter, for people who have problems to solve. There's lots of developers who'd love to partner with you on that and get involved to actually try it out and put it to use and help ideally build new applications or new ways of interacting with your data so that it's even more accessible to more folks. So thank you so much. It was great to chat with you, and please do get in touch. I'm Momac28 on Twitter, and I'll be in chat. Thanks.